Good morning, everybody. Thank you for coming. It's a good crowd. Let's see how hot this room gets. Just a couple logistical things. As part of this presentation, we're going to be doing some interactive Q&A. I'm going to be doing some live demos. So I need your participation for this to be successful. So please ask questions, shout suggestions. No suggestion is wrong when it comes to performance tuning. We have some little prizes, a bunch of Oracle t-shirts, and at the end, a best answer. We'll get a second, third edition of this lovely book, which is the book on the subject today, called Java Performance Tuning, from a few folks that used to work at Oracle. My name is Leonid Igolnik. I have been with Oracle for actually not that long. I joined the company through the acquisition in June. Oracle acquired a company I used to work for called Taleo, and prior to the acquisition, Taleo was the third largest software as a service company in the world. We build tools for HR, human resources departments, that help them manage their talent. So recruiting, onboarding, performance management, compensation planning, learning and development. And I'm responsible for product development of several products. And I'll talk more a bit about my background when it comes specifically to performance tuning. Just a couple housekeeping items. The conference is on Twitter, so if you're using Twitter, follow us there. We also have a hashtag, JDD Krakow, that I'm certainly going to go and monitor after the election. So if you want to tell me that it sucked, or it was okay, or any other suggestions or improvements, just feel free to put it on Twitter. We're also on Facebook at facebook.com JDDconf. And if you want to follow me, I'm on Twitter at LIGOLNIK. Today, we'll talk a bit about me, just to give you a background on where I came from, and it's always important, right? As a speaker, it's all about me, because I have the microphone, and you guys can't override that. We'll talk a bit about you, because for me for this presentation to be interesting and successful, I need to know a bit about the crowd and what do you guys do to make sure we don't go too complex, or also don't go too easy, because some of those tools are available, have been available for a while, and always pains me to know that a lot of people don't use them or don't know about them. And unlike a lot of other people from Oracle you may meet, I'm not from the sales team, so all the tools I'll be showing you today are $0, available for free. And actually, most of them probably have them on your laptop today. We'll talk about just a basic theory about performance tuning and related concepts to lay a foundation on to the live demo that I'm going to be doing. We're going to do a bunch of live demo and debugging, and then I'll talk about some suggestions for further reading. There's several talks, including talks by a gentleman who heavily inspired this talk, Kirk Pepperdine. Kirk talks a lot on performance tuning and actually collaborates a lot with Oracle team, specifically the Visual VM team, which is one of the tools I'll be showing today, and the NetBeans team, as well as some recent talks I saw on the subject from guys at Twitter. There was a great talk at QCon last year in San Francisco, as well as some other reading. So without further ado, all about me. This is me, somewhat lighter and younger, but you know, I still like this picture. So I started my professional career actually coding in Perl, and a lot of people go, ooh, Perl. It's not fun. It actually can be quite fun, and I was fortunate enough to work with a lot of smart people and maintain fairly scalable, and you would be surprised to hear that, fully object-oriented systems in Perl. But I started my career in Israel working for one of the earliest ISPs in Israel, and for the life of me, I was looking for a highest resolution logo on the internet, and I couldn't find one, and then it hit me. Back in the 90s, you didn't have a high resolution logo. That was what we used to have on the website. So most of my professional career, I used to build applications that run online, and most of them were designed to power a business of some kind. After that, and it was kind of interesting because I remember my first time getting on the internet was using the operating system that still scars me, Windows 3.11, using this thing, Trumpet Windsock. And those of you that may remember Trumpet Windsock, anybody here use Trumpet Windsock to connect to the internet? All right, few. You probably downloaded from Tucows, right? And it's kind of funny because I remember downloading it from Tucows, and eventually when I moved from Israel to Canada, I ended up joining Tucows and as a company, which was kind of cool. Little did I know that Tucows actually was not just about shareware libraries, but in late 90s, Tucows gotten into the domain registration business. So around 99, Network Solutions lost their exclusivity for registering .com, .net, and .biz domain, .org domains. Those were the only three available in the TLD. And OpenSRS, when I worked there, and there are a few other folks in the room that actually worked there with me, was the second largest registrar in the world at the time. And that's where I started working on Java. So I started working with Java probably 2001, 2002. Eventually, that led me to my employment with Taleo in California, and that's where I'm based right now. I live in the Silicon Valley. It's always good to leave Silicon Valley to remind ourselves how good we have it with the weather. Especially yesterday evening as we were walking from the dinner. It was kind of chilly. And as I said, Taleo got acquired by Oracle. As I said, Taleo is a talent management application, so I'll just give you a bit of a context of the type of stuff myself and a few other folks that are here in the room from Oracle and Taleo work on every day. So this talk is about 90 minutes, and in the next 90 minutes, our applications will process about 4.8 million transactions, so kind of something like 898 transactions a second. And when we say transactions, we don't count the static images. This is somebody literally interacting with software. Our customers, and we have close to 6,000 customers using this product in a pure software as a service environment, will post about 720 jobs. About 30,000 people will apply for a job using our software. 726 of them will get hired, which is kind of cool. Last year, we processed 5% of everybody who got hired in the United States through our customers, obviously. So that's the type of applications, and the tuning tools, concepts, and ideas that I'll be talking about apply to that scale, but they also apply to applications that run at smaller scale. And to help me tune this talk for you guys, I'd love to learn a bit about you. So we'll do a bit of a polling session, and the way it's going to work, if the statement applies to you, please keep your hands up. If it doesn't, take it down. So let's start from the basic. Are you a developer? All right, okay, it looks like we're at the right conference. Are you leading a team of some kind? Technical? Okay, we got a few leads. Manager? Okay, we have a few strugglers. Let's see, architects? All right, mostly developers, good. Executive, anybody? Okay, good, thank you. We're at the right conference then. So, the products I build, are they built purely in Java? All right. Are they not built in Java at all? Okay, just double checking that we're at the right conference again. They're not built in Java, but they still run on the JVM, things like JRuby, Groovy, etc. All right, the good news, sir, you're at the right talk because a bunch of the tools I'm going to show still apply. Contain more technologies other than Java in the overall application. All right, few, well, more than few. All right. They're designed to power a business or solve a particular business problem. Okay, so we all get paid for what we do, and they're web-based applications. All right, the next one is really interesting. Whose applications don't have to scale and scale fast? Anybody here? Let's do it in the reverse, because otherwise I think the entire room will have to raise their hand. All right, that helps. Let me learn a bit more about your tools, because it's also important. Are you developing on Windows? Okay, about just over a third. Linux? Mac? All right, few. Something else? What's that something else? I'm just curious. Solaris, all right. You must work for Oracle. All right, and when you deploy, do you guys deploy them in production environments to Windows? All right, thank God. Linux? Okay, mostly Linux. Other Unix flavors? Okay. Anybody deploys in production on Mac? Because if you do, I want to talk to you. I would like to understand why. Any other OS that have? That one makes me curious. So what other operating system? Mainframe in Java. Okay, again, I had to double check. I didn't remember we had a JVM. All right, and then the applications that you use by, and that will help me understand the scales you guys are dealing with. Are they used by hundreds of users a day? Keep your hand up if it's more than 100. All right. Just keep your hands up. This is a different one. More than 1,000? More than 10,000? More than 100,000? More than 1 million a day? All right, we have few stragglers. All right. I have no clue. Anybody? You just didn't raise the hand because you didn't know? All right, so that one is actually important because as you think about performance tuning, and that's something we're not going to be covering in today's talk, it's very important on how to set up your objectives. And your objectives really depend on what is that the application has to do in the production environment. So it's really important to know how many how many users or what transaction volume, so what type of scalability you have to put into your software design and architecture in order to hit those desired benchmarks. All right, so I think I have a good idea about you guys. Let's talk about performance tuning. And we'll start with a basic theoretical foundation. I didn't invent it. I went to the source of all truth and knowledge in the universe, also known as Wikipedia, and I just cut and paste that. It's lazy PowerPoint programming. So performance tuning is the improvement of the system performance. The motivation for such activity is called performance problem. Which can be real or anticipated, and we'll talk a bit about that. Most systems will respond to increased load with some degree of decreasing performance. That's absolutely true, although it's interesting. I've seen systems that actually perform better when the load is higher, because you have things like warm-up of the JVM, you have things like warm-up of the caches. It's really application-specific, but most of the applications I had the fortune or misfortune of helping with performance, they actually don't scale well, otherwise nobody calls you. If you have an application that scales better when you have more load, you're actually in good shape. And then, of course, as part of this, you assess the performance of the app and you modify the system to handle the higher load, right? That's performance tuning. But there are two important things that I wanted to highlight here, and kind of two keywords that I think about when it comes to performance tuning. One is there has to be a performance problem. I know a lot of us engineers, we like to think about performance problems. Obviously, nobody here writes a code and say, hey, you know what? I'm just going to write this sucker up, put it on production, and hope for the best. Although I met a couple of guys like that. They typically don't stay employed for too long. But all of us try to write code that scales well. The problem is, today we're more and more involved with systems of ever-increasing complexity, almost exponential complexity. So anticipating the actual performance problems you're going to hit on the production environments, when the system goes out of scales, it becomes extremely difficult. Now, it does not mean that you have to or can ignore best practices, right? I'm a big believer of learning from other people's mistakes. They already paid the price. I see no reason to do that. So you have to remember that the best practices are not necessarily optional, right? And we will have some examples as we go through the live demos. But it's important, and quite often the performance tuning exercise comes in when the system complexity looks something like this. The customer yells because the system doesn't respond fast, or if you're a bank, you can't process your batch at night on time, or if you're a high-speed trading house, your orders don't execute fast enough, and your competitor is a few milliseconds faster. And it's kind of crazy. I have a couple friends that work on Wall Street. They're optimizing for milliseconds. They're moving data centers closer to the networks of the actual exchange houses to gain extra milliseconds on the performance. But quite often, you're also doing those analysis under what I would call duress, because you either have a customer yelling at you on the other line, or you have a big executive in a nice Armani suit standing behind your desk and saying, can you fix that? Now, the good news is, in crisis, there's always an opportunity, which means if you need to do something on production environment that you couldn't do for 10 years because the cloud operations teams or the IT guys wouldn't allow it, but you need to do it to performance tune, most likely you'll get permission. If you don't have some of those tools, most likely you will get your permissions. That's important to remember, because you will be stressed. I've done those performance tuning sessions at 2 a.m. in the morning. Never fun, especially if you've been drinking the night before. So let's talk about systematic approach to performance tuning. Like, this is a typical wheel, right? We need to establish acceptable behavior. We need to have a reliable and consistent method of measuring the performance of the system. And measurement is extremely important, because since the systems are complex, not every change you're going to make will produce the desired result. And if you cannot measure what happened in the system, you don't know if you've been successful or if you're moving into the right direction. So anything you want to tune, you have to be able to measure, whether it's a response time, whether it's the garbage collection throughput, whether it's startup time. It's extremely important to have the right tool for the job, the tool that can measure it with the right resolution. And it's also important to remember that, much like in quantum mechanics, observing the problem sometimes changes the state, right? So you have to make sure that your tools are minimally invasive to the problem, or find alternative ways of measuring a particular benchmark that you're trying to optimize for. Obviously, the key part is identifying critical parts, and I'll talk a bit about that. The most important thing in performance tuning, especially if the system that you've never seen before, and sometimes you have to deal with that, right? The guy that wrote this thing left a couple years ago, you know, in charge of maintaining it. And yesterday night, a big customer ran something through it and it didn't work. Ever happened to anybody? Tuning somebody else's code? Yeah? Always fun, right? So how do you do that? Especially if you're looking at the code base that has 1 million lines, 2 million lines, 15 million lines. Don't look at the code. The important things are look for the tools that will give you a vector into the code. I was never able, by just simply observing the code, say, you know what? Here's the problem. And that's how we're going to fix it, and that's going to fix performance. And I'll show you a couple problems today that seem absolutely benign. And yet with small little tweaks, if you have the right tools, you can find exactly the root cause for the problem. Obviously, you have to be able to modify the system. You have to be able to remeasure the performance, and then the vicious cycle continues until you reach the acceptable goal. So we're going to be talking and doing a live demo on those 4 bottom quadrants. We're not going to talk about establishing the acceptable behavior. You can probably do a talk of 2 to 3 hours on what's considered acceptable behavior depending on your application type. And it's really very dependent on the business you are in or the type of applications you're building. I'll give you a few examples. If your system is heavily batch-oriented, most likely acceptable performance may be measured in the success of the batch completing in the specified time. If you're building interactive applications like what we do at Oracle Taleo, acceptable performance can be measured in response times by the server. It could be measured in render time in the browser. It can be measured in ability of the system to handle concurrent users, as some of our largest customers, for example, go through a performance review cycle on the same day, 400,000 employees, and of course nobody likes to do them on time, so everybody does them at the last time, last hour of the last day, right? And everybody hits the system. So it's an art and a science, so we won't cover it, but today we'll talk about measuring performance. And in order to be successful at measuring performance, the most important thing is to know your tools. And I'll tell you a bit of a story about tools that was a bit of an eye-opening for me and helped me understand why tools are important. Many, many years ago, I was talking to a friend of mine who's a builder. He builds houses. And I walk up to his work truck, and we open a drawer, and he has 4 drills. And I go, dude, I have a drill in the house, and I kind of managed to do everything I need in my house with 1 drill. Why do you need 4? Well, he goes, this one is for concrete, this one is for wood, this one is very light, so if I have to climb on the roof, I don't have to carry an extra load, and this one I don't remember, but it was a nice drill, so I bought it. The important thing here is don't save on tools, even though the tools I'm going to be showing today are free, like in Zero, free beer, and also know what is the right tool for the job, because I'll show you today that having the right tool for the job gets you to the bottom of the problem sometimes much faster. Unfortunately, actually most of the tools I will be showing will be Oracle tools, but one of the tools that I will be showing today comes from IBM. It's an Eclipse tool, and in that particular case, it does certain things better than some of our own products, and it's okay to use it. So know the right tool for the right task and know when to go to that tool. Also know your operating system, whether you're on Windows, Solaris, Linux, mainframe. Know where the logs are, because it's extremely important to understand what's going on in the system. Know how to assess the system's performance. You know, is your application running slow because somebody else consuming all the CPU? Could be. The IT team won't always tell you. They'll just tell you, hey, this thing is slow. Can you come and fix it? Right? Maybe you're running out of I/O. Maybe you're running out of memory. Hey, maybe you're running out of memory bandwidth, which is a worse situation. We'll talk a bit about that. Memory bandwidth, actually, especially in Java applications, where we rely on garbage collection to do a lot of work for us, is extremely important. So maybe you're just running out of I/O bandwidth. So knowing the operating system that you guys deploy to, not necessarily develop to, is extremely important because you will have to tune on that operating system. Know your runtime environment. Know your application server. And if, God forbid, you're running on IaaS, actually know that too. I have to give Microsoft credit. They built a lot of interesting tools that allow you to introspect a lot of things that go on in production as you run applications. And I have the privilege, and maybe a dubious privilege, of managing one application that Taleo has acquired that is written in Microsoft stack. And over time, it will move to the Oracle stack, obviously. But in the meantime, it still has to scale, and we learn and understand the environment in which we're running. Know your runtime environment. As you know, at Oracle, we like to have a lot of everything. So we happen to have 2 JVMs, although not for too long. Eventually, JRocket and Hotspot will probably merge. But if you're running on Hotspot, do a better understanding and spend some time reading the documentation and understanding what hotspot all about. And this Java Performance book has a lot of good content on that. If you're on JRocket, do the same. I actually have to give Oracle credit because it was tough to find some of this documentation with Sun. I remember hunting for those little shreds of how to tune hotspot on the internet and keeping a special file and making sure that file never gets lost, because it was impossible to find all the tuning flags, all the command line flags. Now you actually go to our website and we have pretty decent documentation, easy to read, easy to find. You can actually Google for it and find it. So spend some time reading on that, and again, if you're running on Microsoft.NET, hey, read that too. MSDN has a lot of interesting resources that will help you get your applications to perform, because in this day and age, quite often, our environment will be mixed. It will be some Java, some Ruby, some Perl, some Microsoft stuff, maybe some mainframe still. So it's important to understand each of those unique environments. I won't show some of the tools, but if you're running on Unix, some of the basic tools that you have to be able to know and know how to use is top. Right? It will show you what's going on the CPU. We'll use an equivalent or similar, a tool similar to top here on the Mac to do some troubleshooting with one of the systems. One of the performance problem we'll be solving. Know about VMstat, so you can monitor the system performance over time in a textual nature. And I'm a huge Unix bigot, so I love my shell, even though with the Mac, it's actually kind of easy to transition into visual tools. So no tools like VMstat, no tools like IOStat. And you know what? Know your JDK tools. How many of you have ever run anything from Java home bin other than Java C and Java? All right? Okay, third of the room. I just did an LS in my own system. There's a ton of other stuff in there, and all of it is actually pretty useful. And there's a reason we put it in there, because it is useful. But people just don't know about it. So spend some time, just do an LS and learn about tools like JPS or JHat, JInfo, JStat. I will show some of them, but those tools on the production environment can save your life, especially in the middle of the night, when instead of having to call somebody and figure out how to get it done, you can just well, sometimes you'll need a root, but that's a different conversation for a different meeting. You'll be able to get some of this information yourself, and it's amazing how. Well, JInfo once saved my life, because we thought we were running one GRE in production, but we actually were running a different one. So all the tuning parameters we've done in the performance lab were awesome. The app was supposed to scale, and then you put it on production and it just melts. Fortunately, at 3 a.m., one tool told me exactly which JVM is running for that particular application, and we solved the problem in about 10 minutes. But if I didn't know how to do that quickly, I would probably spend more time struggling. So let's do a bit of a demo on some of the tools that I use a lot. One is called JInfo. It basically gives you a bit of a runtime environment and configuration of your JVM. So I'm going to drop out to shell, and let's see. Are those fonts big enough that you guys can read them at the back? Yeah? All right. So I have a sample app. We're just going to get it running. We'll come back to that sample app in a moment. Let me just get to root so I don't have to deal with issues. All right, so we have this demo up running. Its process ID is 52761. And let's start from JInfo. Not the manual page. Although, by the way, the good news is, if you want to know more, everything ships with man pages. They're very extensive and actually pretty accurate as well. So let's do this. Java home. Oh, that's right. I need to set my environment. Java home, bin, JInfo. And the process ID. All right. So it attaches to the JVM remotely. It will give you things like, let's just quickly scroll. It will give you things like what hotspot what VM are you running, what mode is it in. Another problem that hunted me once, and thanks to that tool was solved. In our production environment, you had to go through a proxy to go out. But the proxy settings were not set right, and proxy settings can be set on the JVM through the command line as a parameter, and I will show you parameters. So all the parameters that the app has. What's the home directory for the user? What's the home directory for the app? Where the temp files goes? There's a lot of useful information here. So using this in the production environment before getting started to make sure that you know what's running is extremely valuable. And it's there. You have it on your computer today. Let's see what else. The other one that I use a lot is a tool called JMap. And JMap gives you a good understanding of what's going on with your heap, right? It's not the end-all, be-all, and there are better heap analysis tools, but if you need something quick and dirty, it's always easy and useful to jump and do that. So let's try JMap. Same application. Ask for the heap data, right? So here we go. I'm running a configuration. I have all my heap tuning parameters here. I know how is the JVM configured in terms of maximum heap size, survivor ratios, and all the garbage collection parameters that I need. I can get the current statistics, and I gotta tell you guys, I'm pretty good at reading garbage collection logs. We'll get to that in a second. And thank God we now have an option on the JVM, so the garbage collection log timestamp is not relative to the application start type. I want to find the developer who coded it and thank that person personally, because I remember sitting, and a lot of our applications are long-running JVMs, so 11 days in, trying to correlate garbage collection log with an actual application log and trying to do the timestamp calculations at 3 in the morning after being drunk the night before. Never fun. So very easy, very useful to get some lightweight information. And here's the first quiz question of the day. So one of the things that JMap shows is number of intern strings and how much they occupy. So who here knows for an Oracle t-shirt, and we'll make sure we have the right sizes after that if it's not the right size. Who here knows what intern strings are, and why is that important to know how many of them are on the JVM? Yes, sir. That is correct. And for the bonus point, where in memory are they? Permgen, that's right. So come grab your t-shirt at the end of the talk. So intern strings are strings that implement a design pattern from one of the driest computer science book I've ever read in my life, the Gang of Four book of patterns, the flyweight pattern. And that they allow you not to duplicate the string information more than once, right? Much like Booleans can be, that actually brings up another story. We were tuning an application once, and we were doing offline memory analysis, and we found 3 million instances of big Boolean object in memory, which is kind of interesting, because how many guys, how many instances of Boolean class do you think there should be in memory at any given point of time? Any ideas? More than 2? No? Right, there should be 2, and it's kind of crazy because if you use Java as Java intended, you won't have more than 2, but that particular application, we took the Boolean from a constructor to a value off, and I think we saved like 20% memory, just with one line, with the tools that we were able to use. Similarly, we've done some analysis on another application at Taleo, where we load a lot of metadata from the database. And a lot of our metadata across multiple tenants is the same. We're using the same keywords. And we were duplicating stuff left and right, hundreds of thousands of instances of the same string for no good reason. Now, you do have to be careful. Those strings go into permgen, and you can force the string to go into the permgen using the factory method called intern on the string class or object. I don't remember if it's a static method. But you have to be careful to go into permgen, and until JVM 8 comes out, permgen is not infinite, and you get into other problems. All right. Let's see what else we've got. Oh, and the other, we don't want Firefox here right now. The other useful tool that I use a lot is JStack. And JStack will give you the thread dump of the application. Now, let's ask the audience a question. So how do you get if you don't use this tool, what are the other ways to get a thread dump out of a standalone running process on the left there? Sorry. All right, kill was a signal 3, correct. And where will the thread dump end up? Output of the application. Do you know STD out or STD error? Actually, it's STD error. But the problem is, if you're running on the environment that you don't know, well, you don't even know where STD error is going to go, right? Like you show up to an application you've never seen on a server you've never touched. Where the hell are you going to find this? Like on TopCount, typically it's in Catalina out, but if your production guys have changed that, it's going to end up somewhere else. at 2 a.m. in the morning, again, this is all about that elusive phone call you get at 2 a.m. I don't want to think where it goes. Now, if you're running on Linux, it's very easy to find. You do ls on /proc/bid/fd/3, and you're actually going to get a symbolic link, because if you think about file descriptors, 0 is std in, 1 is std out, 3 is std error. You're going to get a symbolic link right to where that is. But I don't want to think about it. I just want to run a tool. So here's another tool that is on your machine today. It's called JStack. Let's try running it. Here we go. Here's my thread now. Now, the other interesting thing as well is this version of the JStack, unlike the other one, will also tell you if a particular frame has been jittered or not. And there's another talk later today on micro benchmarks, where it's extremely important to know whether this particular thing has gone through a compiler optimization or it's still interpreted code. And I actually don't know any other way of easily determining that for a running thread. Go to the micro benchmarking talk. I'm sure you'll find out more about that. All right. So those are some of the basic tools, and this one actually on a Mac is kind of buggy, so it doesn't want to die, so you have to help it sometime, multiple times. All right. So those are the tools, and it's very important to have those tools at your disposal and in your toolbox when you look for problems. So let's talk about looking for bottlenecks. And you know, before we get into this, I want to talk about something Kirk Pepperdine likes to speak about, and that's his term that he has coined. Quite often when you try to optimize the performance of the application, the best way to go about it is find what is that dominating consumer. And I'll let you guys read the quote. The dominating consumer pattern can be applied to CPU, I/O, etc. But if you think about the CPU, what can consume the CPU? We have the operating system, we have the user space in which the JVM runs, and then within the JVM you have the JVM internal stuff, such as the JIT compiler, the garbage collector, and then you have the actual application. All of this competes for CPU time. So one of the techniques, and Kirk has pioneered that technique, is looking for that dominating consumer and then trying to understand why is that a dominating consumer, right? So from here on, we're going to jump into live demos, and I'm going to be showing you guys an app. And we're going to go through a bit of a hypothetical scenario. So I have this little app here, which I've already started. One other thing is important. If you're doing kind of standalone benchmarks, you have to remember that applications sometimes take time to warm up. So you need to make sure that you take the warm-up out of the equation. So you may need to exercise the application for a bit. And the warm-up time for each of the applications, you're going to be looking a little different. So you have to use the same tools that I'll show you today to understand what it is. But the warm-up time is important because during the warm-up time, the application doesn't behave as it does in steady state, right? So I have this artificial benchmark. And guys, I have to warn you, some of those examples may seem dummy and simple. It's for a reason. We only have about an hour left, a bit less, to go through them. So they're simple by design, but they're illustrative of problems I've seen other people find in applications and actually that we have found in our own applications. So I have this little thing. A warm-up, and you know it's running. You can press enter, and it's running, and it just timing itself. It prints something every 10,000 iterations, and it runs for 0.36 seconds, 336 seconds. And you get a call from a customer, and guys, hey guys, listen, the contract says it has to run in less than a second, and if you don't really get it to run in less than a second, you're in trouble, and you have about a week to do that. All right. So let's see what some of the tools that we can do that with. So let's start from the first tool. One of the most interesting and most underutilized tools today, in my mind, that ships with your JDK today is called JVisualVM. So how many here have used JVisualVM? All right, so this may be a boring talk for a lot of you then. Let's see, maybe I'll be able to show you something new. So here's JVisualVM. VisualVM can connect to both locally running applications as well as remote. Obviously, for the sake of simplicity, we'll focus on the local stuff. So let me just start this up again and show you a bit about JVisualVM. So as you can see, the app is running here, so we can attach to it. Now, JVisualVM's fonts are not easily controlled. So can you read at the back? Is that still reasonably visible? Yes, no, no? All right, we'll try to zoom in and highlight certain things if needed. So, basic screen when you connect to an application. And actually, I don't have a stock JVisual VM. JVisual VM has a plethora of useful plugins, and I'll show you some of them that don't ship with JVisual VM or are not inside JVisual VM default plugin directory, but there are a bunch of other plugins you can always find and download. And the best part, you can write your own. And I've seen people write plugins that are specific to their tools. For example, if you have a particular information you're surfacing through JMX, you can write extra plugins just to interpret that and visualize that for troubleshooting to give your operations team, for example. All right. So let's look at the basics. So you have some basic data on the environment, arguments that were passed to the VM, system properties, basically a nicer way of consuming JInfo in my mind, because it's roughly the same information. You have a monitor tab, and you basically get to monitor a few things. You have garbage collection right here on the left, and you can see the CPU usage of the app as well as the GC activity. You have your heap statistics, and PermGen is kind of hidden because you rarely need to look at it, right? So you know how much heap is allocated, how much is being used. You have your number of classes, and you have your number of threads, including daemon threads. So another bonus question here. Who can tell me what the difference is between a normal thread and a daemon thread? Yes?
Well, the daemon thread is stopped when the virtual machine is stopped. It's working all the time.
No, not as crisp. Anybody else? Yes.
When we leave only daemon threads, the virtual machine is stopped.
That's right. So how does the JVM know when to exit? It's when the last non-daemon thread stops. So for whatever reason, you're trying to shut down your server, and the darn thing will not shut down, and your IT team is yelling at you because they have to kill it with -1, like I just did. Most likely, you have to look for that extra thread that is non-daemon thread hanging around. Grab me later for the T-shirt. And conveniently, right inside Visual VM, you have this thread analysis tool, right? So right now, this thing is pretty idle, but you see those threads. And the most importantly, you see them visually. And sometimes we humans are visual creatures, and it's much easier to analyze the information when it's nicely visualized like that. And this will come in handy when we start troubleshooting this application. You can trigger a thread dump right from here, and it's actually nicely formatted. It's kind of nice colors. I'll show you another plugin that you can analyze that. You can do some profiling. I'll get into that later. You can analyze, and this is a plugin, if I remember correctly. You can look at I/O pools if your problems are around I/O. You get a lovely representation visually of what's going on with garbage collection, because those of you that have seen GC logs, I remember first time I had to read the GC log. I needed like a user manual, an encyclopedia, and a printout, and another friend to keep me sane from to keep me from jumping out of the window, because they're not easy to read. They were not designed for human consumption, and yet we as humans are asked to consume them. So there's a nice visual way of looking at what's going on with the JVM. It looks like we were leaking space for a bit, or something is running in the system that is ever increasing right here on the right side, the amount of space in Eden. Eventually GC will hit and it will disappear. You can trace particular probes. There are a bunch of probes. Again, that's another plugin. You can trace for things like I/O buffers, Java collection usage, etc. Can come in handy. And that's it. And we'll get into deeper features around JVisual VM in a second, but let's get to troubleshooting this application. So we know it's slow, and one of the first things I want to do is I want to understand why is it slow and what's going on with the CPU, for example. So we're going to start with the CPU activity monitoring, and this is my machine. I'm running 4 cores. Let's get it to steady state so things are actually, let me just see what's running and see if I need to kill anything. Because you obviously want to get your environment as steady as you can in terms of eliminating unnecessary consumers, and it doesn't look like I can kill anything, so we'll just deal with that, right? So this is our steady state. Let me run the app and see what happens. All right. So what do you guys see? What just happened on the CPU? Let me do another run, and it's still running 4 seconds, way far from the sub-second response we're looking for. So what can you tell me about what happens when this application running? Anybody? What's happening with the CPU? Just 2 cores, okay. So we're not using all of the CPU we have in the machine, which is a problem, right? Especially if your problem is not I/O bound, you probably want to grab as much CPU. Anything else jumps out? And maybe I should explain what you see here. If you remember, the CPU time is always split between the kernel time, the system time, and the user space, right? So the JVM runs in green, and this kernel time here is in red, right? So does anything jump out at you when this application runs? Sorry? I/O? No, this is CPU, so there's no I/O here. So on this chart, you wouldn't see any I/O, and for the sake of time, I'll tell you there's no I/O going on. So anything else? Let's run it again. Let's look at the CPU utilization. So we know that we cannot utilize the entire CPU. So now we need to look for the dominant consumer. So what do you guys think is that dominant consumer? Is that the user space CPU, or is that the system space CPU? I'll give you a little hint. Every time you see system time spike above 10%, there's a problem. Most likely that's something that prevents you, because every time you have to run into a system time, there's a context switch, right? The user space application has to make a system call. There's a context switch. It's a very expensive operation in most operating systems. So that's typically where I would start. I would look at the system time and see that it's pretty high. So let's look at what's going on. Let's try using Visual VM and see if we can figure out what's going on. Now we know that if you think about the JVM, the times you have to make calls to the system, it's external I/O, it's probably memory, it's probably things, especially when you're running in a multi-threaded, multi-CPU system. It's also probably about locking, could be. But let's see. Let's not guess. Let's grab the demo up. I'm going to connect to it. I'm going to go to thread monitor, see what's going on. Let's shrink the CPU monitor a bit so we get to see everything, and kill this window. All right. So right now the app is idle. Let me start it, and let's see what is going on. All right. So again, we see in all the threads, we see that the app started, a little thread pool was about 9 threads. Does anything jump out at you guys? The legend is right here. Green is running, purple is sleeping, yellow is wait, and red is monitor. Anything jump out at anybody here? That's right. Threads are not running. It's kind of fun. We have a lot of stuff. We have a lot of threads, but they're all not running. And conveniently enough, Visual VM colors them in red, because if you have a lot of red, it means you're waiting on something, and you're probably waiting to lock something. It's not your I/O wait or sleep wait. It's your monitor wait. You're trying to enter something, or you're trying to obtain a resource. Okay. Well, now we need to figure out what resource it is. So again, let's try to find that vector, because I don't want to guess. This application could be 3 million lines. I don't want to try to guess what's inside there. I want to get a vector right into the code, and ideally into the line of code, using a tool like this, and then look at the code. So let's try it again. So I restarted the app. Let's get it rolling. We'll kill the CPU history for now. As you can see, it's running, it's idle, it's waiting for me to hit enter. So the first thing I'm going to do, since threads are competing for the log, actually, what do you guys think the first thing I should do now to figure out where they're? Okay, but how do we know what are they? How do we find out what are they competing for? We know they're competing for something. How do we know? Yes. That's right. How do you do it? You grab a thread dump. Conveniently enough, in this tool, I can just click this button. All right. Now, you can obviously read the thread dump like this, but Visual VM has a lovely plugin called Thread Dump Analyzer, and we'll just use this. And again, the reason I like Thread Dump Analyzer, it just gives me an answer right here. I have 28 threads, 6 of them are waiting for the monitor, 5 are sleeping, and 8 are locking. Interesting, 8 are locking. Let's look at those 8. Oh, look at that. Pool, there are a bunch of JVM threads that I probably don't care about, but my threads and 2 of those are locking at the same time. And the other good news is, one other advice, if you think as you're tuning your application, the bug is in JVM, stop. The bug is rarely in the JVM. And I had a personal experience where we were trying to troubleshoot an application that was written in Perl. We found a bug in Linux kernel, and we were very happy because it was a reproducible bug in the Linux kernel. We patched it. We sent a patch in. It's in the Linux kernel. It was about mutexes. We declared success. We drank champagne, and 3 weeks later, the problem came back. It's unlikely that the bug is in the Linux kernel or the JVM. It's probably in your op. So if you look at the stack trace, look at the op. And the only class I can see that is the domain class is this, demo op person store get person line 28. Remember the idea of getting a vector directly into the source code? That's the stuff you're looking for in the middle of the night. All right, so let's look at that. Person store, line 28. All right, I'm going to make this fonts just a bit smaller. Can you guys still read it at the back? All right, so line 28. Let's look at this. So, what do you guys think is the problem here? Synchronized, yes, big anti-pattern. People that don't understand concurrency like to spread synchronization keywords through their code. And that leads to people that get paid a lot of money to tune the performance of their application to charge a lot of money to remove those keywords. Love that keyword. Love that keyword. So what do you guys think should be the fix? It's a very simple class. It has two maps that I guess act as caches and one writer and one reader method. Any suggestions? Well, straight to concurrent hash map. All right. Let's try something else first. But actually, no, you know what? Let's go straight to the concurrent hash map. And like any good cooking show, it so happens that I have another version of this class already prepared, just fresh out of the oven with concurrent hash map. I think I guessed. I had a premonition that somebody's going to say concurrent hash map. So let's look at this code. Tell me, does it look good? Is that how you would want it to be with concurrent hash map? All right. No? Okay. What are some of the problems? You get a bonus point because I actually missed that bug when I wrote this code. So come see me for a t-shirt. Yeah, you're right. But for the sake of this presentation, let's assume as a good business person, I'm going to change the business rules on you right now. Let's assume that it's okay not to have consistency between those two caches. Fine, that's my exit. I'm the speaker, I'm the guy with the microphone, so I'll make the decision. All right, so any other problems in this 7 lines of code in which I managed to make 2 bugs? Sorry? For what? Why? All right. Do you guys, anybody here in favor of putting final in? Who is for final? It's a democracy. Okay, 1. Who's against final? Everybody else abstains. It looks like you got outvoted, sir. But let's try it without final real quick. All right. So I just saved the app. Let me compile it. Wow, my machine is running really slow. The hell is going on? You know, could be. I'm going to blame, I'm going to call Cupertino and tell them that they broke my Mac. All right, so it's compiled. Let's run it again, see what happens. It's warming up. All right, so before it was running like 4.85 seconds. 2.6, that's not bad, right? We're almost halfway there, but not quite there yet. So let's see what's going on. Let's grab the CPU history, get this stable. You know what, I'm just going to exit the activity monitor so we have a clean start. All right, let's get this running. All right, so what do you guys see on the CPU? Are we able to consume the entire CPU? Almost. And how's the kernel time looking? Pretty good, right? All right, so let's keep digging. Let's look at Visual VM, see what else we can find. So I got another instance running. It's warming up. All right, let's go to the threads. Run it. Wow, we're doing pretty good. It used to be red and very long. Look how quickly it finished, and it's all in green. So, okay, we solved one bottleneck, but there's got to be another bottleneck. So let's see what else we get to see here. Let's look at the monitor a bit. So that's interesting. So you look at the CPU utilization, about 17% got spent at some point of time on garbage collection, right? And garbage collection is can be another dominant consumer of your CPU. I'll show you another tool that I use to look at this. So this application, when it runs, it has a couple extra flags. I've asked it to produce a garbage collection log with garbage collection details and timestamps. Now the log you get will look something like this. And again, you can read it with the encyclopedia, and if you know what it is and you read those a lot, you kind of get used to what they say. But there's a lovely tool, and it's a free tool. It was maintained by a company, got abandoned, now is picked up by the community again. And there's more than one tool. This is the one I prefer. It's called GC Viewer. It's a tool that will allow you to look at garbage collection log. You can download it from the internet, and it's not installed where I'm going. It's actually installed in the stocks directory. So let's say java-jar GC Viewer 131 jar. All right, so the way GC Viewer works is you open a file, and again, like in any other good cooking show, I already have opened that file in the past. Now, this is a very small garbage collection log. I have another example from a real-life production application. This one is, I think, 11 days worth of logs, and you can scroll around and see how the app warms up and the cache. So there's a lot of interesting data. And the good news is this viewer works pretty well on applications that run for, well, very long time, as you can see. It's still scrolling. We'll stop. Can I stop it? Stop! Wow. When all else fails, there's always the kill command. Gotta love Unix for that. Right. So let's grab our run. So here's our GC log from our small run. We're going to have to zoom in. I guess people don't used to having. So what do we see here? You get to control different things that show up. So you have your tenured generation, you have your young gen. You can see when GC runs, right? Full GC, bad, generally. And you can see how much GC was running, right? And as you can see, we're slowly warming up the application. So this is the warm-up time, right? The cache is warmed up. And then we're running stable. And then the memory increases all of a sudden. And garbage collection, like this little utilized heap, starts hitting in back and forth. To me, that's an indication of we are producing a lot of garbage or a lot of memory. Now, in Java, and I'll tell you another side story. I studied with a lot of folks that ended up in embedded software, so they write OSs for digital cameras, DVD players. Some of them used to work at Palm when Palm was trying to make a phone. And we always argue about merits of assembly and C, because for them a complex language is C++. And Java, and one of the reasons, and they don't believe me, so we do a benchmark sometimes. Allocation of memory in Java is cheap. It's a big miss that allocating objects are expensive. Allocating long-lived objects is expensive. Allocating cheap, small objects that are very short-lived is cheap because in Java it's a simple pointer bump. Those of you that remember from computer science how malloc has to be written with things like memory fragmentation, ooh. Or those of you that are fortunate enough to use .NET and know what large object heap is, where objects cannot be moved around, and that creates that fragmentation. None of those issues exist, but it's still a problem. And one of the interesting things you can see here, we are, we're freeing about 2 gigabytes a minute of memory. Sounds like a lot, right? For the app that's supposed to run for a few seconds. 2 gigs a minute, and the overall footprint of the app is only 400 megs. That sounds like a lot. And by the way, I mentioned to you, it's important to understand your runtime environment, right? Well, maybe 2 gigs a minute is the maximum that your memory bus can allow. So it's always nice to know in some cases, what is the spec? Can we write that much over the memory, from the CPU to the memory bus with 2 gigs, right? What else? GC performance, we're collecting, on average, we're only able to collect about 51.8 megs a second, so we certainly keeping up, and we had 18 pauses in this about 3 seconds of runtime. So the next thing I would want to look is, because I think my theory right now, the reason the app doesn't run fast is that because the dominating consumer now is the GC. And I'll show you how, again, using the same tool, Visual VM, you can very easily confirm it. So let's get the app running again. One of the things you have in Visual VM is a lightweight version of our NetBeans profiler. It's absolutely free. Other people charging money. We're all about giving to you for free. And you have both the sampler and the profiler. And today I'll show you a subset of the functionality that the profiler offers. So we are all about figuring out what's going on with memory, right? And how do you find why you're creating that much memory? Well, you could look at the code, but we know that looking at the code is not going to give us what we're trying to do. And what we're trying to do is we need a vector directly into the line of code that is the problem. So how do you do it? Well, conveniently, this particular profiler allows you to do what's called object allocation profiling, including recording the stack traces for where those objects are being allocated. I love that. Stack traces gives me a class name, a line, a method. I can just go inside and look. Ain't that fun? Now, remember, every time you profile the application, you probably don't want to destroy the performance of the application because profilers can be pretty invasive. If I have time at the end, I'll talk about a new sort of solutions called APM solutions. The number of companies like New Relic, AppDynamics, obviously Wiley has the Interscope product that are designed to be profiler-like, that run on your production environment without significant impact, or at least some vendors claim without significant impact on your performance. So you can do that, but with this particular tool, let's say we're going to grab every thousandth object, right? So we are running, we're going to get memory, we're going to start the app, let the profiler do its thing. All right, so are we done yet? No, we're still running. As you can see, the runtime is now horrible, right? 11 seconds because of the profiler. But I'm not looking for the time. I'm looking to understand what happened with memory. So also, it just generated a heap dump. So I look at the heap dump, which is an offline snapshot of the JVM's memory. And right now, it's sorted by bytes allocated. But let's first sort it by objects allocated. Oh, wait, it's the same. Anything jumps out at you guys?
String concatenation.
String concatenation. Ain't that cool? Right? Right there. So now the question is, where the hell are those strings coming from? Sorry? I don't know. I'm not going to guess. But conveniently enough, and by the way, well, we'll get to that in a second. So let's look. Show stack traces. I don't have to guess. I know where they're coming from. 100% actually. 15,966 samples come from string builder to string get person. Do I get a line number? No, that's unfortunate, but I guess I'll have to manage. All right, so somebody said strings in keys in the map. Probably correct, so let's go look at that code. Keys in the map. Yes, probably right here. Nasty. So, any ideas on how we can fix that? Sorry? Simple class, and what would that class do?
Be a pair of first name and last name.
With equals and hash code and put first and last name.
All right, double bonus points. And again, as I said, like in any good cooking show. You could do that, but since I didn't pre-cook that one, we'll go with the first suggestion, conveniently. And I did not pay the gentleman to do that. Yes, I created this compound key called person key, and as it was correctly highlighted, that person key, and I'll show you guys the class, it's pretty trivial. And again, we're not here to solve all performance problems. We're going to learn about the tools. First name, last name, hash code, and equals. Maybe not the most pretty implementations of hash codes or equals, but you know what? I don't care. Whatever NetBeans generated is good enough. Until I determine that those things run slow. I'm not going to perceive this as a performance problem. All right, so person store, any other changes? So now we have a concurrent hash map, as you guys wanted, with a compound key. Any other changes, or should we give it a try?
Flyweight as a person key.
All right, we could. Any other ideas? Flyweight as a person key was one. That was a tricky question, by the way. I don't think, and just keep in mind, when you're doing performance tuning, your best bet is to do one thing at a time. Measure it. Because if you measure something, and you're not going to know which of those extra changes that you made have compounded. So I would absolutely consider fly weight for the person key, but after I do this. Because the other thing I want to tell you is, if this gets me to the performance I want, is it really important to put a fly weight as a person key? Do I want to spend the time? Let's see. So we have this. Let's compile it. And let's run it. See what happens. My God, 587 milliseconds, 10 times of performance improvement on what seems to be a simple app with 5 lines of code with the right tools without having to guess. And that's the important part. And the same tools and techniques that I showed you are used by people that charge a lot of money to come and do that on applications that are millions and millions of lines of code. Those are the same tools we all use. It's no different. We use those tools at Oracle Taleo every day, and I'll show you a couple other ones. But the key message from here is, as you tune, know your tools, know your metrics, and look for the tools that give you the vector into the code. Don't look at the code first. You will never find it, right? With the right tool and knowing what to do with the tool, you can get into the line of code that most likely is the problem. So we have another demo, and we have time, which is good. But before we jump into the demo, I'll pause here and see if you guys have any questions.
Is there a CPU history equivalent in the command line?
Yes, so depending on your OS, and I don't like the one on a Mac, so that's why I don't show it. On the Linux, there's a tool called vmstat. I'll just Google for it. It should be online. So this is the tool, and there's an article from Linux Journal on how to monitor the usage. So let's see if they have a sample output. Here we go. Let's just make it bigger. So you run vmstat, you determine the interval, and you will get a few things. You're going to get number of running processes at the OS level, number of blocked processes, number of waiting processes, some memory statistics around swap, free, buffered, and cache memory. Bytes out and bytes in, so some I/O stats, and most interesting things, what you're looking for is this, system CPU. And actually, this tool gives you a third useful piece of data. So you have your user space, you have your system space, you have your idle time, but more interesting here, you have this context switches. So how many times in the interval that you specified on the command line, the OS had to do a context switch and take one process off the CPU and put another one because a process either was either blocked on I/O or blocked on something else, right? High level of context switches is indicative of some kind of resource contention. It differs, and you have to baseline a steady state to understand what's normal for your environment and your application. But we watch for those things, and if context switching goes up, it's an indication of some kind of contention, because the schedulers in kernels are generally designed to let the app run on the CPU for as long as you can, because otherwise you have to move it out of memory, you have to get the stack swapped. Context switching is not a cheap operation. So if you see a lot of that, something else is going on and you're getting some contention. Any other questions? Yes?
I would like to ask about two things. The first thing is remote sampling.
Yes.
Memory, and sampling of the latest version of JVM versus older version of JDK and issues with that.
So two things, two questions. Sampling remote, yes, possible with Visual VM. You have to do some black magic and sprinkle some dust in order to get it to be able to connect to the JVM. So it's not always possible with all the firewalls, but quite often, surprisingly, a lot of production environments still have X Windows deployed, and there's nothing wrong from running Visual VM locally, but projecting it to your local machine using remote X screens. So X11 Unix style. And I've done it a number of times. It's kind of slow and sluggish, but it could be your only way. And if you can do Visual VM, though, you can always fall and look at things like JSTAT and JSTAT-D. And I'll leave it as an exercise for a reader. The second question was older JVMs. Yes, the success you're going to get with with this tool is obviously much better on the more modern JVMs. Is anybody still running 1.4 in production? Okay, there's one person who is scared of admitting that. Oh, yeah, well, I can't help with that. But we sell another service. If you want to upgrade, we are happy to send a sales team your way. They will sell you a license for WebLogic. Anybody running 1.5? 6? 7? Who's running 8 in production? Nobody is that brave. So 1.6 and 1.7, you're not going to get into any of those problems. Those tools have been stable and fairly reliable for those two JDKs.
JVMs that most likely will work, but what about plugins?
Same. I have not seen, and we're fortunate enough, we've been running 1.7 for a while. I haven't seen any issues, but you may run into some compatibility issues. But you know, where one plugin fails, another one will succeed. There are plenty of plugins, and right inside JVisual VM, you have this lovely catalog of plugins that they endorse. Like I have 11 installed. There are more, and you can always install your own plugins that you just download off the internet. Like that little thread dump analysis plugin is not an official plugin, but a plugin that I grab off the internet. All right, any other questions? Okay, we'll do one other demo and we'll leave some more questions in there. And so I have another app, unsurprisingly, that behaves differently. That one is a tricky sucker. So let me run it. Oh, it froze. Oh, it froze and it ran out of memory. That is nasty. Ever happened to anybody here? Apps running out of memory? Yeah, some people? Everybody else is not willing to admit. Okay, that's a problem. Especially if they run out of memory in the most random times, right? If you're running a production application with variable loads and variable system conditions, you never know how they're going to run out of memory. So, any suggestions on what we would do if the app runs out of memory? Sorry, too many people. Somebody, raise your hand. Buy RAM. Okay. All right. Okay, increase the allocations. Let's assume we already maxed out the chassis, so there's no more RAM to be had. There's like 2 terabytes of memory in this sucker. And by the way, it's watch the Twitter talk that I'm going to reference at the end of this presentation about what happens when you switch to 64-bit and the size and how the size of memory pointers affects the heap you get to utilize. It's some interesting data on that. So we can give it more memory, but I heard somebody suggesting getting a heap dump. And again, you can do a heap dump through visual tools, but quite often, especially for the problems that happen unpredictably, you want the heap dump when the thing has run out of memory. Because quite often there will be an application that runs out of memory, and then it recovers. Right? You kind of hit the memory threshold and something crashes, and then the garbage collection comes in and goes, oh, yummy, I have a couple gigs to collect, gets it out of the system, and the app is all up and running perfectly. And then the customer calls and say, hey, guys, did you know, like yesterday at 3 p.m., we couldn't use your application? You go, no, I don't know, it's running. The JVM is doing OK, right? So Java, conveniently, and again, it's a flag that you used to have to search for and pay people like under the table to get the actual parameter. Now it's properly documented. That allows the JVM and forces the JVM to drop a heap dump, which is a binary representation of memory, when the JVM runs out of memory. Now, it's an operation and a setting that you have to use carefully in production, because on a sizable JVM, 4 gigs, depending on your 4, 8, 16 gigs, depending on the I/O you have on the server, that heap dump can take 10, 20, 30 seconds, couple minutes. So you have to apply this sparing, because in the meantime your app is not running and your monitoring is going crazy and the NOC is probably getting paged. So you need to know when you're comfortable doing that, but you can do that. So let's do that. So let's run this application and get a heap dump. As I get a heap dump, keep in mind the size of this H profile will be the size of your JVM heap. So be ready to have a lot of disk space and a lot of memory on the machines where you're going to be doing the analysis. Some tools are better at that. Some tools are worse. It used to be the case before certain tool shows up that you needed at least double the amount of memory you have in the heap dump to actually successfully analyze the heap dump. No longer the case. And also keep in mind when you move those files around, especially if you have to get them from the production environments, they're large, but they're highly compressible. They generally compress something like 10 to 1. So, a heap dump. Let's first try this in a visual VM. Is my visual VM here? Yes. Let's get this one running. Oh, I'm running as a root. Bad idea. I've never run it, so let me just do this real quick. So let's look at the heap dump in a visual VM, because in visual VM you can also load a bunch of stuff. You can load profile or data, thread dumps, but we will go and load the heap dump. And this stuff is on my desktop in the bin, nope, not in the bin directory. It's in the demo app. It's in build classes. Here we go. So you get basic statistics on how many bytes are there in the heap, how many classes, how many class loaders, how many objects are considered what's known as garbage collection routes, so they're at the top of the garbage collection hierarchy. This heap was obviously generated based on out-of-memory exception. You get some standard properties, and then you can start looking at the classes. And here's one. What do you guys see? What jumps out when you look at this heap? Sorry? Ah, yes. Yes, caching again. Memory leak. Good point. All right. So what's leaking? So we have a lot of strings, right? What is it? 979,000 strings. And we have about 500,000 person objects. That's a lot. And then we have this weird thing called weak hash map entry. We'll have to talk about that one. Now, for the sake of the time, I'm not going to show you again how to use allocation profiling. We know where this thing is happening. So let's assume we've done that allocation profiling, and we know that the problem is in this peculiar named class, weak cache. Every time I see a class, hand-coded class called cache, that's always a natural suspect. So let's look at it. It's a very simple cache. And I suspect somebody wrote it with best intentions, and I'll tell you why. It's using this implementation called weak hash map, and let's quickly see what weak hash map is all about. Here's a Java doc description. So weak hash map is a hash table-based map implementation with weak keys. An entry to this map will be automatically removed by the garbage collection when the key, my emphasis on the key, is no longer in ordinary use. That's awesome, right? If you think about it, such a great idea. I'm writing a cache. I want to make sure that, you know, if our application needs more memory to run, that cache gets cleaned up automatically. There's this thing that comes with the JVM. I don't have to do anything. Cool. Let me do that. So obviously somebody read that online and did that. So let's look at it again. When I look at it, and when I first, and by the way, this is from a problem that I dug up in the real production application, also in the middle of the night. I was sober that night, though. It was not really obvious as to what the hell is going on. So I started looking, and if you know what's going on, bear with me, because there's a reason for why I don't know what's going on yet. I want to show you guys another tool that makes it very visible. But it's not obvious what's going on here, right? So I went to another tool that I like to use for offline heap analysis. It's called Eclipse Memory Analysis Tool, or MAT. Comes from Eclipse. Happens to cost exactly $0, 0 cents, and downloadable very easily. Eventually it will start up. Now, one of the reasons I like this tool a lot is its ability to do parsing of heap dumps, and its ability to do parsing of those heap dumps and caching the data. So next time you have to open that 6, 8, 20 gig file, you don't have to go through all of the CPU. So you pay the penalty once, but everything else gets indexed and cached, and then you can do some crazy stuff. I won't show you a lot of the crazy stuff in there, but the crazy stuff that it does, for example, with OQL, Object Query Language, will allow you to write queries that answer questions. I think I told you about interning strings. We wanted to do a count of how many duplicate strings we had in the system. You can just write a query, almost SQL-like, against the heap and figure that out, and calculate how many bytes you're going to save. So OQL is very useful if you get into offline memory analysis or heap dump analysis. So we will show you, and of course it helps, and by the way, it has a great tutorial, but the first thing it opens, it goes, yeah, let me show you a leaks aspect report. All of the reports that it does will run in the background, so you can always kind of send the sucker in the background. It will wait for it. And here's our leaks aspect report. Yeah, something stands out here, right? This little problem suspect. Let's look at the details. My God, look. Same thing. Demo app, weak cache. Retained heap, 98 megabytes, right? In the element data that we have. That's a lot. Let's see what we can find about it. So you can either browse the data, or you can start with this lovely histogram. Again, you get heap. You also get a calculation of retained heap, which is important because you have to have a shallow heap. For example, for a hash map or a collection, shallow heap is the footprint of that collection. But you also, the tool will pre-calculate everything that collection holds to. So we know we have a lot of strings, we have a lot of person objects. You can browse, and you can see I can double-click and list objects. One of the things I love about this tool, you can list objects with outgoing references, so as if you were browsing them in the debugger. Or you can actually do the reverse, which is more interesting. You can get the object with incoming references, i.e. what else is pointing to that object. So let's start with outgoing references. Just show you an example. Here's all the list. There are 490 of them. And again, you can write little queries here as well. But let's grab one on the left. I can see all the attributes. I get some basic statistics. I can look at the class hierarchy, right? So this is a very simple object, as you guys can see on the left here. It has 2 strings and an ID. Nothing too fancy, right? Now, we know that we have a lot of hash map entries that are supposed to be released according to the Java doc that, for whatever reason, are not being released. So somebody is holding the reference to the key. And in our case, let's look what the key was. So let's grab those hash map entries. Let's grab those with outgoing references. So here's one, a sample entry. It has a next, it's a linked list. It has a queue, it has a value, and a referent. Right? So string and a person. If you remember our class, string and an object, and the object was person, right? So, interestingly enough, right here I can say, well, that string is, I guess, referenced by something, so let's figure out what is still holding the reference to it, so I don't have to guess in the code, because obviously something is not coming out of the reference count. And now I'm going to get a list of all of those objects with incoming references, i.e. who points to that string, right, in a click. The next question is for the big prize, the book. So whoever gets it right gets the book. So I get those 2 references. Does anything jump out at you guys? The value points at the key, that's right. So we have a person that sits inside a map, but the key of the map is also referred by that person object, and you can see it here. So this is the first reference is from the hash map entry. Let me unfold it, right? Right? So this is the referent for this string. Now, the value, the person, actually also refers to that exact string, and that's a problem in a weak hash map because it will never get released that way. And if you've seen this problem once, it's obvious, but again, if you're debugging this sucker in the middle of the night, whew, that was painful. So yeah, so how do we fix it? So since you had you saw the problem, how do we fix this?
You have to change the key for something which is string. You can call the string, create a new string.
All right. Can I type? All right. So what do we do next after we build? What are the next steps? We just made a change. All right, let's do it. What's our measurement in this particular case? What's our criteria? What are we measuring?
Appearance of the stack trace.
All right, appearance out of memory error probably, right? Because that was the problem. Well, let's measure it.
Another option in this map would be to use the object as a key, also as a value to be released.
All right, good idea. Let's see. Well, that seems to be running already, so I think we're kind of out of the woods. Now, again, guys, this is a very simplistic one-liner problem, but it's meant to demonstrate the power of some of the tools to look for that needle in the haystack, right? It's in a real application, this heap would have been filled with millions and millions of objects, and finding the right one without having to imagine a complex problem, especially if you have never seen this before, is extremely important. So, as I wrap up, I wanted to give you guys further reading. We'll leave as much time as we can for Q&A, but they're important for me to show you a few things as well. So, as I said, a lot of the stuff I do is inspired by the work of Kirk Perpendine, and Kirk has a blog. He's been talking about performance tuning for many, many years. He specializes in the field. He has a lot of interesting presentations. There was another recent presentation by the James of Attila. I won't butcher his last name, but he works at Twitter in their performance optimization team, and the talk is available on the InfoQ recording. Highly recommended. And then there's the book by Charlie Hunt and Binu John. I've been running Java applications and optimizing their performance for over 10 years, and I read the book recently and I learned something new. And get a copy of this because you will, and it's available. Excerpts are available online. This one is for you, sir. Unfortunately, it suffered minor damage in transit. So we'll do it a bit differently before I jump into the Q&A and get kicked out of here. One other thing, we have another gentleman here who just ran out of the room. It wasn't somebody who didn't like my talk, I hope. Jakob is presenting on RESTful Java with JAX-RS. He's a committer and contributor to Jersey. He's doing a talk in the next slot, so somewhere next door. And the other reason I'm also here in town, and you guys should know that Oracle is in town. We are actually in town. We just opened a sizable office right here next to in the Quattro Business Park. Taleo had an office in Krakow, and through the acquisition of Taleo, Oracle now does. We're expanding this office. We just built in 2 new floors in that building. They're brand new, pretty cool. We're finishing the final touches, and we are hiring, and we have positions for managers, tech leads, software engineers, QA automation people. We're probably going to have about 100, 150 people in this office in Krakow by the end of the year. We're going to start with our application business, so Taleo applications first, and then other product lines may follow. So if you guys want to talk to us about that, there are a few Taleo Oracle folks in the room. If you can raise your hand. See Robert at the back. Martin is here at the front. We have a few other folks on the floor. So if you want to talk about what we do, what we're looking for, just come and find me or one of the guys. And with the time we have left, let's see how much we can answer. Any other questions? Going once? Any other tools? So the other class of tools that piqued my attention recently is a set of tools called APM, Application Performance Monitoring Tools. Not all of them are free. Some of them are commercial with free versions. And some of the tools I would look is UpFirst, UpDynamics. And Taleo has been using UpDynamics for a while. We actually, products that I run, we have UpDynamics running in production on every single JVM. And it gives you exactly what I showed here. It gives you a vector into the code without a lot of penalties. The performance penalty from running UpDynamics for us is about 2 to 5%. And we were very skeptical when they told us that. The gentleman that started the company is an ex-chief architect of Wiley's Interscope product, so they obviously know their stuff. So that's another product I would look at. What other tools do we use? To be honest with you, nothing much more. JMeter, if you need a better test harness than the one that I just wrote by hand, is highly recommended. I know, Martin, Robert, any other stuff that we use routinely? Those 3 are pretty, like the Visual VM, offline memory analysis, and some of the tools that are built into your OS kind of typically get you 80 to 90% there. You know, profilers are interesting. Because due to the complexity of the systems that we run, profiling the application and the development environment, it's kind of pointless. Because we get hit with tens of thousands of transactions a minute or a second sometimes. So recreating that environment in the lab is impossible, and that's why we invest a lot in the tools that run directly and collect the telemetry on the production environment. One of the products I'm responsible for does something very unorthodox. We don't load test, period. And we handle 50, 60 million transactions a week in an easy time. We don't load test for one reason. We have telemetry that you wouldn't believe coming out of production environment. And we release frequently. And I know there's some talks on continuous delivery, but if you have good telemetry and you release frequently and your application is sufficiently lean, and you have a reasonable team with other checks and balances and controls in your process, you can get away without load testing. Because load testing for real situation is extremely, extremely difficult, right? Recreating those complex traffic patterns, and we're a publicly facing internet application, is extremely expensive. So we tend to gather most of that data from APM tools, again, like AppDynamics, in lieu of a profiler. Maybe we'll resort to a profiler, and again, if you're looking for an inexpensive, decent profiler, actually a pretty good one, NetBeans profiler, also available inside Visual VM, is a great start. Any other questions? One last question.
You show us an example of profiling,
Yes.
analyzing the requests.
Mm-hmm.
Can you have you got any experience with continuous test of performance?
So the question was, I've showed per iteration or per instance of application analysis, and that's mostly because I had to do it in a demo and had to be pretty quick about it. Same techniques apply to what you're asking about. Can you do it continuously? Some of the stuff was Visual VM and capturing snapshots, and Visual VM has ability to compare those snapshots for you, right? So you can put two snapshots side by side. When we think about continuous performance tuning, we again rely on the set of tools that are application performance monitoring tools, right? Again, AppDynamics, AppFirst, New Relic, etc., that give you that type of telemetry continuously. They use statistical analysis, right? So they obviously don't monitor every request, but some of them are smarter than others.
There's no information when you use, for example, another analysis tools like
All right, I suggest let's talk about this offline, guys. Thank you very much for coming, and enjoy the rest of your conference.